Hey everyone, my name is Cedric Clyburn. I'm an OpenShift developer advocate, and thanks for joining me for this hands-on intro to cloud-native CI/CD with OpenShift Pipelines. We're going to start with a brief overview of CI/CD and more specifically what cloud-native CI/CD is. We'll introduce some OpenShift pipeline concepts, and then we'll be making a real-world pipeline right here, all in under 10 minutes guaranteed. So if you're like me about 8 to 10 months ago, you're probably wondering, what the heck is CI/CD? I've gone ahead to do the work and pull up the definition from the Red Hat website, and I believe it really encapsulates what the process of CI/CD is. CI/CD introduces ongoing automation and continuous monitoring throughout the lifecycle of apps, from integration and testing phases to delivery and deployment. And essentially, CI/CD has a few different meanings. The CI part in the front refers to continuous integration, which is an automated process for developers like us. Think about the building, the testing, and the merging processes in a GitHub repo that we're used to. This can help solve issues of having too many branches in your app in development at once that could possibly conflict against each other. Now the CD refers to continuous delivery or deployment. Each kind of get used interchangeably. However, what's important to note is this helps illustrate just how much automation is really going on. For example, continuous delivery means that devs' changes to an app are automatically bug tested and then uploaded to a repo, whereas continuous deployment can refer to releasing a dev's changes to an app to production, where people like you and me can access it. It's essentially the next step and builds upon the benefits of continuous delivery. Okay, so here's the fun part. What is this cloud-native version of CI/CD? So that's a great question. Essentially, this refers to a few different aspects. Firstly, containers. It's got to support apps that run on containers orchestrated by Kubernetes, or in our case, OpenShift. Secondly, it's got to be serverless, meaning it can run and scale on demand without needing a central engine to be maintained. And finally, it's built with DevOps practices, meaning teams can have their own delivery pipelines alongside the apps they build without dependency on other teams. So, in conclusion, our CI/CD should be able to perform all of this with this in mind. Now, there's plenty of options for your projects to choose from. For example, we've got Jenkins here that we use at NC State University, Go Wolfpack, among many others. However, the one we'll be taking a look at today is called Tekton. It's a powerful and flexible open source framework for creating a cloud-native CI/CD system. It's awesome because it integrates into Kubernetes and allows developers to build, test, and deploy across cloud providers and on-premise systems. Now, OpenShift Pipelines is the native integration of Tekton into OpenShift, and it introduces a set of tools that are compostable, declarative, reproducible, and cloud-native in order to make building pipelines as easy as can be. Now, let's quickly go through the building blocks that Tekton provides. Steps, tasks, and pipelines make up the bulk of our CI/CD framework. Firstly, we've got a step, which is an operation that we perform on our code. Say, for example, a unit test on your Python code, which Tekton will perform inside of a container that you provide. Now, the one on our top right will build our app with Maven, and the one on our bottom right will parse our Python code. It's easy as can be. Secondly, we've got a task, which is a collection of the steps that we just mentioned. Tekton runs tasks in a sequence inside of a Kubernetes pod, and it can run independent of pipelines. Finally, we've got the pipeline. It's a collection of tasks that can be run in a variety of ways using different conditions that specify when to start the next task. It's great because these are reusable across projects, saving both you and me valuable time that we could be spending on homework. However, both task and pipeline share input and output resources, which kind of help with this reusability bit I just mentioned. This could be a Git repo, PRs, images, all sorts of things. Lastly, we've got task runs and pipeline runs, which simply define the execution of a pipeline. Now, we'll talk about this more later on through the lab. Here we can see it all come together, and feel free to take a screenshot and check it out later because these pipelines are honestly fascinating. But let's get to the fun part of installing and working with OpenShift Pipelines. As we mentioned before, OpenShift Pipelines is the native integration of Tekton onto the OpenShift platform, and it offers all of these great features to developers. To install it, simply head to the Operator Hub on the OpenShift web console, search for the Pipelines operator, and then install it from there. The web console provides some neat visualizations for your pipelines, but I'll be using the Tekton CLI for the rest of this demo to show you how dang easy it is to make your own pipeline. Now, if you'd like to follow along through this demo and don't have an OpenShift cluster ready, simply head over to learn.openshift.com, where we have a browser-based lab that will allow you to follow along not just with OpenShift pipelines, but also with Quarkus, serverless AI, and a whole lot more using OpenShift. Sweet, welcome back to the terminal. where I'll be showing you all the concepts we just mentioned out in a live cluster. Firstly, let's log in, and I've already got my high security credentials set up as user admin with password also admin. And once we're in, I'll head over to the web console to show you how easy it is to install OpenShift Pipelines. And then we'll come right back. Now on the administrator side logged in, let's go under operators to the operator hub, where we can see all the available operators for OpenShift provided by Red Hat and our awesome partners. Let's search up pipelines and let's install the latest release to our cluster. It might take a minute or so to install, so let's head back to our terminal in the meantime. For this demo, we'll be creating a simple web application for voting that involves both a front end and a back end. Let's keep this organized in a new project, and for this, we can call it Pipelines Tutorial. Sweet, we're good to get started. The foundation of Tekton is made up of tasks, which kind of define the steps that we'd like to run. Let's take a look at a basic Hello World task, which is comprised of a simple YAML file that includes a metadata name we can use, a step which pulls the Red Hat UBI image, and it runs a command to output Hello World to the terminal. Let's apply this task to our cluster like any other Kubernetes object and run it using Tekton, the CLI tool for Tekton. After a few seconds, it should output Hello World into our terminal. Awesome! Now let's look at adding parameters into our task to pass various flags in the future. This is great for making tasks more reusable, just like this apply manifest task, which we'll use in the future for deploying an image on OpenShift. Let's apply this task and take a look at another task that we'll be using. This update deployment task takes in the name of the deployment we'd like to update, as well as the image location. We can apply it and then move on to the resource we need to apply before we get to our main pipeline. This persistent volume claim provides a file system for our pipeline execution, which we're also going to need for this specific pipeline. Now, once we've applied this, let's review the task that we created using Tekton. This is super easy with the command tkn task ls, and we can see the 3 tasks that we've already created. Neat. Finally, let's take a look at the pipeline we'll be creating today, which is a bit hefty but highly reusable. You'll notice that many different parameters such as deployment name, GitHub URL, and version, as well as tasks such as fetching a repo and building an image using Builda, and links to the previously applied task to make everything come together. This will help us build our back end and front end by configuring the right resources to the pipeline. You may have noticed that there wasn't any references to specific Git repositories in the pipeline, and that's where the last step of pipeline run comes into play to execute everything perfectly. We'll first build our backend using tkn pipeline start, and I'm going to go ahead and copy and paste this command in to fill in all the necessary parameters using arguments in our one command, such as persistent volume claim, git repo, and image. It'll take a few minutes for both commands to run though, but you're going to see the real-time progress in this pipeline for both pipelines creation in the terminal, which is super cool. Once the commands finish up, you're able to see the list of created pipelines with tkn pipeline ls, and see the specific pipeline runs with tkn pipeline ls, where now you can see both of our API and UI pipelines. Fantastic job. At this point, we can either access the full application using the terminal, or for a cool visualization, we can head to the web console, select our pipelines project, and you can view both the backend and front end pods hosting our web application in real time. Now just hit the root for the UI pod and you'll be able to access the created application and finally vote for your favorite animal, which of course should be the dog. Okay, wow, I just compressed an hour conference talk into 10 minutes, which may be a new record, but to review, we learned about OpenShift pipelines, the various concepts which make up CI/CD, and demoed a cloud-native CI/CD pipeline, all in a very short amount of time. You're now prepared to start making your own pipelines and continue on this journey of CI/CD. Thank you so much for watching. My name is Cedric Clyburn from the OpenShift Developer Advocates team, and to learn more, head to developers.redhat.com or learn.openshift.com for more interactive scenarios. Take care.